Welcome to a lesson with Dr. Powell. Let's take a look now at the integration of x bar for the wire that we've been discussing in the last couple of videos. We already came up with an integral that looks something like this. And now let's actually work through that integration. In the last video, we actually computed the arc length. To be approximately 14.15. And if you continue it off in the expression that we have, there's more to it, like 3, 2, 9, 3, 3, and it keeps on going. So this is the arc length that we actually computed. So we'll need that as we go along, but let's go from here. So remembering what we're doing, we're taking the average value of x as a function of m, so with respect to m, over a mass interval or an arc length interval, because mass is equal to arc length of the centroid on this wire. And the total mass length of the interval is the arc length itself. So 1 over that times this. So it's really the average value of the function x. And with these different variables going on here. So what we're going to do, so basically I just have these here to notate what the setup for the integral was and why. Okay, so we're doing this integration here. Okay. So in doing this, we can distribute the square root to these different parts across the sum. So we have, let's see, we have 2t root 4 plus t squared. And we can distribute to the 1. So 4 plus t squared. So we have two different integrals to work with. Actually, one of them we've already seen before in the previous video. We don't have to work through it again because we already did it. All right. We can reuse what we already did and we already obtained. That'll make it a little simpler. Then we have 1 over arc length and 1 over arc length. In fact, even if we didn't do it in the last video, we actually know something right now. This integral right here itself was the integral to compute arc length. This is 1 over arc length. They cancel each other out. So this is like arc length times 1 over arc length. It's just 1. So this whole part is actually equal to 1. Isn't that beautiful? That was fast. And now this over here, we can use a u substitution. And it'll go fairly quick. This is u, and actually the derivative of u is sitting right there, 2t. So 2t dt is actually translates right over as du, or you could think of dt as being replaced with du over 2t, and the 2t's cancel. So essentially, really what we have here is we just have u to the 1/2. So u to the 1/2 is what we're now taking an antiderivative of, and we have change of bounds. When t is equal to -2, we actually get 4 plus 4, which is 8. And when t is 2 root 3, we get 3 times 4, so 12, plus 4 is 16. We get 16, just double check to make sure that's right. Let's see, 12, and now it should be right. Yeah, okay. So we get from 8 to 16, and then we have, so we have this integral. We have 1 over arc length, so AL, say, and then this is just plus 1. So this is what we have so far. And this is a lot simpler to work with. We can take an antiderivative right here. That's u to the 3/2 divided by 3/2, which is like multiplying by 2/3. And we're evaluating that from 8, 16. Let's just do this integration. We're gonna multiply by 1 over AL and add 1. So while we did the integration, let's do the evaluation. So if you put in 16, so 16 to the 3/2 power is the same as 16 times 16 to the 1/2. It's 16 to the 1/2, square root of 16, which is 4. So 4 times 16, which is 64. So 2 times 64, it'd be 128 over 3. So we're looking at, let's see, 128 Oh, so that's 128 over 3. Right, when we evaluate this part, right? 2 times 64 over 3. Okay, then we subtract off what this is when we plug 8 in. When we plug 8, this will be like 8 times the square root of 8. And what's the square root of 8? The square root of 8 is 2 root 2. Yeah, is 2 root 2. So, okay, so we have, and we're multiplying that by 8 to get 8 to the 3 halves. So that'd be 16. So 16 root 2, then multiplied by another 2 would be 32 root 2. So 32 root 2 over 3. So it looks like we end up getting, okay, 128 over 3 minus 32 root 2 over 3. Okay, and that we multiply by 1 over the arc length, AL, and then we simply add 1 to it. I'm sorry, this is kind of all in the middle, but here it is. And if we work that out, we can get the exact value for x bar. So let's take a look and see what that is. Okay, so checking this with technology, we end up getting for our expression that we've kind of worked out, we get 2.9, so approximately, so x bar will be approximately 2.94878. It keeps on going. Okay, so about 2.9 or something like that, very close to 3. Let's just kind of think about that for a minute. So what are the x values going from? Well, when t is -2, we're at like negative. So when t is -2, we're at like -3. So x starts out at -3. And when t is 2 root 3, we're at like 4 root 3 plus 1. And so we're looking at, like 7 or 8 or something like that, or whatever. So kind of getting up there. So x bar looks like is kind of somewhere in the middle there happening. So I'm definite and sure about the arc length integral, but assuming that, and the setup is correct, but assuming that the arithmetic was right and the typing in was right, then this would be x bar right here. Thanks for watching.